Okay, so good evening, everybody. Welcome back to the session. Hope you're all able to hear my team. I see my screen as well. Please do give me a quick information so we'll continue with the session. Yes, all of you able to see my screen, able to hear me? Yes. Okay, great. So let's get started, team. Just for a quick recap, I think yesterday we started with configuration management. We tried understanding what is configuration management and how configuration management helps a DevOps engineer to implement his day-to-day activities, as implement any automation or infrastructure changes that you want to implement it in your different environments. We normally use always the configuration management tools such as Ansible, right? Ansible team, it's an agentless architecture. We have it, and Ansible uses the SSH protocol to communicate with the target servers. We understood about Ansible architecture. We understood how to run Ansible ad hoc commands, or before even we understood how to set up SSH key access, right? Now after that, we also started working on Ansible playbook, where we discussed about what is YAML, how YAML works, and everything. After that, we also executed multiple playbooks. Now, apart from that one team, at the last, we also started with Docker. We tried understanding about what is a Docker container, how does it help us move the application from one environment to another environment, bringing the consistency in delivering the application across various environments. Now, along with that, we also understood about the differences between the containers as well as the virtual machines, right? Containers usually have the very minimal OS library when compared to the virtual servers. Now that's what we understood, team. These are all the things that we understood yesterday. We also installed Docker on a machine, right? We also installed a Docker on a machine, and we try to understand that we can have a Docker images public repository, right, which is Docker Hub. Now where you can have a Docker images can be there. Now we will download this Docker images, right? Docker image ls command would show you the local Docker images. This is what we downloaded yesterday, and I also showed you various other commands. To Docker pull command to pull the Docker images, Docker image ls command to show the images on your system. That's what we did. And apart from that one, we also discussed to inspect the image to know more details about the image. And we also did something called as Docker image rm to delete an image from your local system. I think these are all the things, team, that we understood yesterday, I believe, and we must understand about how to run the containers from an image given. And we also would like to understand how to access an application which is running inside, you know, inside your Docker images, right? That's Docker container we call it. So let's try to understand, team, and how would you deploy this containers in a production level, right? Where we think about how to run multiple containers from a single image, right, into multiple servers and so on. So we'll be understanding and we'll be discussing about the Docker today completely, and Docker and Docker Swarm, and just a quick introduction to Docker Kubernetes also. So those are the things that we will be discussing it. Now, if you have any questions that we discussed yesterday, please do let me know. We can discuss them accordingly. Is everybody clear? Right, so I do see that everybody is good, team. So let me continue with the today's session, where I'll be walking you through the how to create containers from a given Docker image, right? So let's look into it. Now that, team, I have such images called as Tomcat. Tomcat image usually consisting of OS library plus Java plus Tomcat, that we understood. Similarly, the Nginx also, which is having certain operating system library, and then plus your Nginx software installed, and everything will be done. Jenkins, once we installed, can we remove the Jenkins from my Ubuntu? Of course you can do it. Of course you can do it, Atul. Definitely it is possible. Okay. Right. So let's focus on the Docker. I'll give you the necessary steps if you want to uninstall it. Okay. Right. So here, team, I'm talking about how do I run a container? How do I run a container from a Docker image? So Docker image ls, for example, take the Tomcat image or take Nginx image. I have it from which I want to run the from which I want to run the container team. Now, in order to run the container, basically, we need to have something called as a Docker, right? What is the way, sir? How to simple team? How to run a container from given Docker image? This is what I see it, right? Try to understand team, the Docker images can be run into containers in multiple ways, or in fact, I'll say that there are two ways basically we use it. Okay. So when I say two ways, there are this one. Let me increase the font size. Right. So here it is. Great. Now let's say that team, when I say two ways here, there's a first way is that we call it as interactive mode, right? Interactive mode, which means that we need to interact with the container operating system that we have it. Now, the second thing is called as your detached mode, right? Now, let's try to understand what is interactive and what is detached here, correct? Now, when I say it here, team, the command goes like this, which is docker run -it. Let's say that we give a Tomcat image and Nginx. Now, team, whenever you think about interactive mode, basically, right? Whenever or when you think about when you want to see what is inside the container, right? What is inside container, or do something inside, or do something inside container, we call it, right? Now, if you want to do these things, Steve, we normally do an interactive mode, right? And when say that detached mode is that when you think like, right, when you want to access, right, access an application that is inside your container, right? That is inside your container, we call this one. So these are the two different modes, team, that I say it always to everybody. Now let's look at it one after the other one. We run a command here to docker run -d and -p Nginx or Tomcat or whatever the image team. If I want to create a container from a given image, the command is docker run. Try to understand, team, a Docker run would always create a new image, right? So a new container from the given image accordingly. Now, what mode you want to run it, that is your choice. So if I want to run in interactive mode, then I say that -it says team docker run nginx. So this is what it is to do it. But what mode we want to run it is that we need to append here, which is -it. When I say -it means it says that interactive terminal, right? Now consider this one, team. This is your shell terminal of your virtual machine. You do a SSH and you connect to the SSH terminal of your virtual machine that you are running basically, right? Similarly, container is also, or image is also having an OS in it. Now OS, whatever it is, they will have the default terminal again, right? That is right. That is where you must see that I want to interact with the terminal, and I'll give the terminal name because containers does not have a full-fledged operating system, so they cannot initialize any default shell. You must interact or you must request what shell you want to initialize it. Where I'm saying that I want to initialize a bash terminal shell inside the container. Now look at this one, team. Clearly it will create a container and will get inside the container. You might see the difference in the screen. Basically, you see that from root manager, right, I went into something called as root at container ID, which means that this is like your container host name right now, which means that we are sitting inside the container. If you want to check the nginx, because it's an nginx image, say that nginx -v, you can see that inside this one there is an nginx version installed is 1.19.3, right? Nginx is a Docker image from which I'm creating a container. Okay. Now this one, team, consider that now inside this container, what operating system do I have it, right? Cat etc os release, right? If you look at this, there is a Debian operating system inside my container. Consider this one, team, right now. I have ran a container from the given Docker image, right? Consider that you have a host, right? Now inside this you have a OS, which is a host OS or Ubuntu OS, you have it. On top of it, we installed a Docker software. Now we have ran a container, correct? Now this is the container. I have it from the image was just a file and I ran a container. Now container is a runtime format. So inside this container, team, I just have my Nginx software, which was installed. So I was able to validate it. Now you also have something called as OS library, which is a Debian, right? Debian is the OS library that I'm seeing it, right? Now this is how somebody has prepared a container or an image basically, which is having an OS library plus the Nginx software together. They bundled it and they gave it as a Docker image to me, right? That's what I do. So that's what team. I ran it in an interactive mode. I went inside the container. I went inside the container and I validate inside the container what it is exactly there. Now, the thing is that I'm still inside the container. How would I come out of this container is the question, correct? Now, that is where team Docker gives a command again, right? Here to come out of an interactive container, right? Interactive container, use a command called as control, right? CTRL PQ command. Okay. Now this is team just like you use a control C, control V to copy paste the things. Now this is something like control PQ, which is given by the Docker to come out of a running container, which you are inside basically, right? Now I'm inside the container. If I want to go back to my root manager or virtual machine terminal, I'll do control PQ, right? Now this is where you will come back to the container or the Docker terminal. Now there is a container which I created. Is it running or not? You must check it. Let's say that in order to check the containers that are running on your system team, we use a command called as docker ps. When I do a docker ps, it will show me that the container which I created is running successfully. Okay, this is how team you can understand about how to run a container in an interactive mode and how to get out of the container, how to validate what is inside, and how to come out of a container using a control PQ command. Okay, so team, does anybody have issues with my voice except Vinay? Right? Team, can you please respond? Do you have issues with my voice breaking anywhere? No? Okay. Yes, yes, no, no. Nope. Okay. Thank you, Pandit. Thank you, Abdul. Thank you, Himanshu. And say that Vinay, I think you need to check. And then Gautam, Gurunath, I'm not really sure. Please check your internet connections once. What's the speed you have it? Most of the people does not have any issues. So please do check on your side also. Maybe if you joined from a web or something, please do check it again. Okay. Thank you so much for the confirmation, everybody. So coming back here, now I just ran a container from a given image in the interactive mode. I was inside, I validated few things inside. Now I came back to my Docker terminal again, or my Windows shell terminal again, right? This is where you do. This is called as a running a container in interactive mode and, using that and coming out of it and validating whether my container is running or not. You can see that. Now coming back here, correct? So how do I run a container in a detached mode is a question, correct? So let's say that here it is, right? So the second thing team here, detached mode, docker run, I will do it. Now you may just see the difference team. I'll run this command right now. Earlier when I hit docker run -it command, it went inside the container, right? Now let me do the same thing here, which docker run, it will create a new container again, but I use a -d, and let's say that I also use -p and Nginx. Okay, so this is where team, you just see that now the difference is that earlier we went inside the container, we validated, and you want to come out of a container, we used something called as control PQ, correct? That's what happened. Now, in order to create a container, right, just say that I just want to access my Nginx, I do not want to get inside the container, then I use a detached mode like this, right? Now, when I say -d, it will just generate a container ID. It will just generate a container ID and will get back to terminal normally again. Now, if I want to check the running containers, I'll just do docker ps, right? Now you see that from a single image stream, I have multiple containers are running. Okay. Now, likewise, team, you can create as many containers as you wanted. Assume that whenever you run a docker run command, it always spins up a new instance of your Docker container, right? It's like at 4 Nginx instances I have it on my system right now. Okay, if I ask you to set up a 4 Nginx instances team, I'm not sure how much time will you take it, right? Because you need to know how to install Nginx, how to start Nginx, all these things you need to take care of it. But here you just run a single command, which is docker run. It will create a container, It will start the Nginx. It will ensure that the container will be accessible for me. Now consider that here, this is what I just did it. So I have access here. Let's say that I can access my Nginx with this port number 32770, right? I'll go here, I'll get my IP address where I'm running it, public IP address, and get inside 32770. Now I see that my page is welcome to Nginx. Means I just hit the container, the application running inside the container, which is Nginx default page, where I'm able to see my welcome to Nginx page, which means that I am able to create a container and I'm able to send a request into the container and able to access the container application running inside the container actually. Now this is how team you must understand about how to create a container from a given a Docker image, which is always you must know it. Always think that you all have to start it in two different ways. This is just for development purposes only, means in the development purpose only where you want to validate, you want to customize anything, then you go for interactive mode. In a production like scenario, we just run the container, we start accessing application. In a production like scenario, we always run in a detached mode containers only. Okay, this is what the understanding that you need to have team. So let me get back to here and try to show you various other Docker commands. Now team, as I told, container is a runtime instance of a Docker image. From a single image, I can create many instances. Each instance is equals to a server. It will take the request, it can serve your request, it can respond back to you with your application accordingly. So once you understood this one, if I want to know more details about the container, right? Now this is where I see it, Docker container, right? Inspect, right? I do it, Docker container inspect. I want to inspect the container. Just do this, right? It will give you a lot of details where you can see the container IP address, right? Containers do have their own IP addresses, right? Container port numbers, whatever the port number that is published for this particular port numbers. Along with that, you will also see that where exactly this is, the status of the container, like this, right? Whatever that is, you see it, the status of the container is running. Is it running true, past, false, and the PID, like as I told, the container is a process. So every process would have a PID on your system. This is your container PID that is running on your system again. So this is how team you must understand about how to run a container and how do I know more details about the container using Docker container inspect and the container ID that you can do it. Now, similarly, team, I can also do the various operations with containers. Is that we can do a Docker container PS also. Container PS command. You see that it will be listing the containers, right? To list the containers, do a Docker container PS. Now I can do a stop of the container also, just like stopping the Tomcat or Nginx process and starting back. Let's see that Docker container stop. I'll do it, and you must give the container ID tip in order to perform an action against any container. It is always that the container ID is the best option that you have it. Okay, so that is what all you can understand. So this is what the container ID team, and apart from that one, you can also stop multiple containers at once using the container names again, right? You can use either a container ID or a container name, it doesn't matter, both works in the same way. Right? You can see that Docker container stop. I do it. If I do on container PS, I do not see the two more containers like this, correct? Now, if I want to start them back, I can simply go ahead and start it. Docker container start. I just do this, right? It will be started back and it will be showing under the Docker container PS command again, right? Now, if I want to restart the containers team, I can also use a restart command instead of stop start, right? A restart, I'll do it. So you may leave this one, maybe I'll try the other one, right? Let's say I want to go with this third container, which is this one, right? Wizardly will hard something. Now you can use the container ID or a container name team, either of them will be fine, but recommended that use the container IDs always. But restart can be done like this. Whenever you do a restart again, you will see that the container gets restarted, means that stopping the process and starting the process automatically. So these are the various container operation team that you can do it always. In case a process does not respond, let's say your laptop does not respond, you try to force shutdown, right? That is nothing but killing the system processes directly, right? Now you could also kill the container process if you wanted. Means if the container does not respond, you could simply kill it. Means docker container kill. I do it and just do this one, right? It will kill the container, right? It is gone. Now, how do I see the killed container or stopped containers team? Is that use a docker container ps-a will show you the stopped, exited, and every container plus the running containers accordingly. So this is what all you can understand about it, right? These are the basic commands about the container lifecycle, we call it team. Consider that you can start, create a container, run the container, stop the container, start back the container. You can restart the container. You could also kill the container. You can look at the containers running on your system with docker container ps command. Likewise, team, there are many commands you have it. Now, can I rename my container? Can I put a name for my container? Is that the question? How the port number manage in docker container? Is it have own a set of ports or the container manage, or it depends on the machine port on the docker is running? Okay, so the question is the next topic, Vinay. Just hold on for that, on that how the container port numbers are managed and all those things. I'll talk about it. Just hold on for some time on that. Once I explain the container lifecycle, then I'll go back to the things accordingly. Can we change the name of the container? Yes, we can change the name of the container. We can use a docker container, right? Rename, you do it, rename and give the name of the container. Let's say that this container, which is this one, I want to give it Pandit, right? I just give this one. Now this container becomes the container named Pandit. Sorry, where is the name of the container? Here it is, right? You can see the Pandit name here, right? See, the container name is Pandit here, right? You can rename a container if you want it, or while creating a container itself also, we can simply give that, right? Docker run, I'll do it, -d -p, the same command. Now --name, Naresh, I'll do it in Nginx. So I can create a container by assigning a name to it also. This is how you do it. Docker container, right? PS, I'll do it. Now you will see a container running with a name called as Naresh, right? I renamed a container, or I just name the container if I want it. You can do whatever you want it accordingly. So this is how, team, you can understand about the container lifecycle. I'm just repeating this process again, team. Look at all the commands that we are running it here, right? We started with a Docker container or Docker PS, whatever it may be. We ran the containers in a detached mode or in an interactive mode, right? Now you keep on running the containers. Multiple containers can be run with a single image. That is possible. Now the Docker container inspect is a command to know more details about the container. Docker container ps is to list the containers or running containers. Docker container ps-a is to list the stopped containers plus started containers or running containers, right? You can stop the containers, you can start the containers, you can restart the containers, you could kill the containers, right? You can rename a container name if you want it. You can also name the container while you're creating a container. So these are all the various operations team against a running container or whatever it may be. Now let's look at a few things also here, which is how do I look at the container logs, right? Container ps, I'll do it. Now if I want to check the logs of a container, what should I do it, right? Means inside the container team, my Nginx is running it, whether my Nginx is writing some log or not. How do I check the logs of it? I can do this one, docker container, right? Let's say that logs, I'll do it, and you must give the container ID or a container name. You can just use it. Now you will see that there are certain logs available. Whatever the logs that is thrown by the Nginx process inside the container, it is just stopping here. If you want to follow the real-time log, right? Now you can do a -i parameter here, which means that follow the log. It will not terminate it if there is a process running it directly. Now you can see that it is going to hit it. Let's say that not sure it's going to write it here, but let's see this one, right? This is how you can understand about it. Okay, you can do Control C to come out of it. Now, along with our team, as we discussed yesterday, the containers does not need resources to be allocated. They will take -f is to follow, means instead of doing the real-time logging, right? Instead of just open the file and keep it open, so it will try to write the log continuously there, following the log, real-time log, if it's writing it already. Okay. So I can also look at the statistics of my containers team. Consider that I do a container, Docker container stats. I just run this command. It will show you the utilization of each and every container, right? Look at this. It is actually doing it, called as Naresh is a container name. It is not utilizing any CPU, but it is utilizing 2 MB out of my 983 MB on my system, right? As I told, like containers are dynamic resources, right? Containers take the resources dynamically. Right now, my container is not having any request on it. It is simply using only 2 MB. If I keep on hitting the utilization, if I keep on hitting 1,000 to 2,000 requests, it needs to process more requests. It will increase the number of memory it is required automatically. So this is how you can understand about the utilization of the Docker containers, that you can see it accordingly. Okay. Now this is how team you can understand about the Docker container lifecycle. How do I run the containers, right, from a given image, right? And how do I look at various commands about the Docker containers here? That's how you need to understand about it. So let's proceed further now and try to understand about how do I remove a container. This is last stage in your container lifecycle team. So Docker container, right? PS into it. Now the containers can be removed also team. Containers can be removed also, right? I'm coming to that today. So let's say that Docker container, right? Docker container rm, right? I do it. I can give my container IDs if I want it again, like this. You can also remove the containers team if you would like to. Means once the container is run, means whenever I would like to change a new version of the image, I will remove the older containers and I'll normally create a newer version of the image and do it. But in this case team, you can see that it says that error response from the daemon cannot remove a running container. Obviously, you should not be able to remove the containers, definitely. And again, here, if I want to remove them forcefully, though they are running it, it is suggesting that you stop the container before you remove a container. Try to understand team, if I remove a container, if there were any changes inside the container, you will lose them permanently. Okay. Remember that if you are deleting a container, if you had some changes inside the container, you made it by any chance, then we will see that you are removing those changes permanently and you cannot get them back again. Okay, so here it is. We can run this command to forcefully remove it. Now this will remove the containers from my system completely, right? Docker ps-a, if I do it also, it does not show me anything, right? This is all the things you can think about it accordingly. Okay, now this is about removing the containers. How do I remove it? Now along with that, the question from Vinay is that how if a container is running in a detached mode, can I get inside a running container, right? The command to enter into the container, think that you can get into the container in two ways. By creating a container, get inside it. That is nothing but we say that docker run -it. When I use docker run, it will create a new container and gets inside that container. That's what we saw at Vinay earlier already. But what if I want to get inside a running container, a container is running in a detached mode. Now I would like to go inside this container. Can I get inside? The answer is yes, we can do it. Docker exec, instead of a docker run, right, I use exec command. So exec is a command to get inside a running container. I use the same thing again. I want interactive terminal, but not this time image name, but it is a container name, right? So that's how I do it here, and bash. This is how you get inside a running container again. Okay, this is not creating a new container. Okay, don't confuse with that. Docker run will create a new container and will get inside it. That is interactive terminal mode. of a new container that you're going to create it. Here we are also getting the interactive terminal for an existing container. That is what is called as your Docker exec accordingly. Okay, now you can come out of the container again using the control PQ. That's you can do it accordingly. Now this is how team you can understand about how to create or how to work with the containers. How to work with the containers. So far I've shown you the container lifecycle completely. That is what is -a. -a is to list the stopped plus running containers. So Docker PS will show you only the running containers. Okay, this will show you only two containers here which are in a running status. Up status is 7 minutes or 11 minutes. If I use a Docker PS-a, if there is a container in an exited state, that also will be shown to you accordingly. That's the only thing. If I made a change in the container and I stopped the container, then will I able to get the changes? No, Pandit, that's what I'm telling you. When you get inside the container, you made some change, right? You came out of the container. If you remove the container, your changes are lost. Okay, you cannot get the changes again. Okay, so that is what is not recommended to do it, but we do something where we can create a Docker images with that. Any command to see remove the containers? No commands. Once they remove, they're gone permanently from your system, Vinay. There is no way that you can look at them. There is no way that you can see them also. Okay, right? So that's how you can understand about. Now let's try to understand about a concept called as how to access an application running on inside a container. So look at this one team. This is the host, I call it. We normally call this, or where you run the Docker is called as a Docker host, or we also known as Docker node. Whatever the name you call it, that's okay. Now this node has an IP address, right, which is a public IP or whatever it may be you think about it. So this node has an IP address, right? This is a virtual machine. I have it. The virtual machine IP address is this. Now, if I want to run or access an application on this virtual machine, how do I access it? What is the way to access an application running on a virtual machine? Yes, team. What is the way to run access an application that is running on a virtual machine? IP and come on, everybody. Right. So how did you access the Jenkins? How did you access the Jenkins, right? Did you access the Jenkins? How did you access it? Which is nothing but IP plus IP colon port, right? This is the standard way of accessing an application, that is running inside a virtual machine. That's correct. That's correct. Good. Now that's everybody correct, right? But think about it right now. Is your Nginx running? If Nginx is running on virtual machine, I would say that IP of the machine, this is get port of the Nginx. But is my container running on a virtual machine or is it running inside the container? Right? So this is a special environment team. Try to think that this is a complete packed environment. The container or the application is running inside the container, which means that my Nginx has a port number available inside the container. Container has its own network namespace, so which cannot be accessed directly, right? Is my AT available on the server? Then I can access the AT port number, but it is not available on my here, right? This is not available here, that is inside the container. So in this case, how do I access an application or a server that is running inside a container? Is that by using or by publishing the port numbers, we call it. Or Docker lets us do a port publish, or a Docker does something called as port forwarding from your Docker host to the container port number accordingly. Now what does that mean again? So let me display that accordingly. Here, Docker container PSL root. Let me remove the container team so that you will understand easily. Docker container RM, right? Right, Naresh and Pandit. I'm removing both the containers. Now let me add the force command -f. So think about it right now. I do not have any container running, right? Docker container. Yes, I do it. There are no containers running. Now let me do a -a also. Let me do all the containers. Okay, I'll do this as well. remove this container also, that's okay. Right, now there are no containers running team, or no containers available either in a stopped state or a started state. Now let me create a container, right? Let's say that docker run -d, right? I'm just doing a detached mode. Let's say that Nginx, right? I'm not using anything in the default one which I'm using it. Now if I go and check it, you'll see a container which is running here. I started a container. The container has a port number called as 80. Now, whenever you see that just the 80 port number, even a single port number here, which means that it is actually running inside the container only. Now, it is showing you only the inside container port number to which I cannot access directly, or to which I cannot reach directly using this IP address of the virtual machine. That is not possible for me. Okay. Now, in order to access an application running inside the container, we normally do something called as port publishing. Means for a run a container, again I cannot do anything. I must create a new container by publishing the port number, we call it, right? For which I will add a parameter called as -p, right? Capital P, that is case sensitive, that is capital P. I do it. When I do this one, Docker does something here, right? Look at this. Docker maps a port number. Consider that. Now this is the port number team. Docker maps a port number called as 32775 and redirects it to the container port number. So what just happens here is that, so it is creating a random port number here, which is 32775, and it is actually redirecting to your container, which means that now I have a port availability on my Docker host. In this case, I can use a virtual machine IP address and the port number of the virtual machine. Now this will redirect your request to the container, and the container will respond back to you. Okay, that's what happens basically. That's how the Docker containers inside applications inside the containers should be accessed. Okay, now you see that I get the response here, right? That is how you must understand the about publishing port numbers. It is also called as Docker port forwarding. Docker does the port forwarding internally so that the request goes to the container and container responds back to you. Okay, so this is the understanding team that you have it. Now in other words, you may ask me now, can I allocate my own port number on my Docker host? Yes, that is also possible. There is a way that you can do it. Instead of a capital P team, just use a small p option here, and left side is always your Docker host port number. And so that I want to put it 8080, 8090 something, whatever the port number you want to put it, give it, and colon, and the left hand side or right hand side must be inside container. What is inside container is that Nginx, that is a default web server. A default web server always runs on the 80 port number, so you can do this accordingly. Okay, now let me get this one. Now in this case, it will allocate my own port number, which is 8090. Now I can send a request to 8090 and the container will respond to me again. So I'll go back here. Instead of 32775, I do 8090. Simple words, right? I can see the response again. If the Docker have two servers running on a different ports, then the port we forward to container, then which application will run on that port? I did not get your question, Vinay. Right here, you see that there are two containers that are running from the same image, right? There's an Nginx only. There are two instances of my Nginx which are running, the both having a different port number. Now, if I access this one, it will go to this Nginx. If I access this port number, it will go to this Nginx accordingly. Is that what you're looking for, or is it something different? So these left side port numbers are your Docker host port number. What is the question, Vinay? If the Docker have two server, what do you mean by Docker have two server running on different port numbers? Say that Docker is a solution here. Docker is a container store. You say that there are two Docker containers running on two different port numbers, right? That's what the scenario you see it here. There are two different containers running on two different port numbers. Now, if I want to send a request into each individual container, you must access the each individual port number of the container accordingly. Is it clear? I still have a doubt. Okay, good question. So can one container have both Nginx and Tomcat running? Means that in a single image you want to deploy both, right? Two services running inside a single container. In that case, yes, I can publish two port numbers for a container. That is possible again, but the recommended approach is that you should never run two different services in a single container. Okay, that is not at all a recommended approach. You should never do it. Okay, we can do it. The answer is yes. For your question, yes, we can do it, but it is not at all recommended, or Docker does not recommend to run two different services like Nginx and Tomcat in a single container. You should be never doing it. If you do so, Docker cannot manage it well. Docker says that it will be your responsibility if you run so, and then I cannot guarantee anything on that. That's what Docker tells you. Okay, I hope that makes sense for you. So here, then they have two ports, and how we map to the Docker container, then it will direct to server. See here, inside the container, your Tomcat has 8080. Inside the container, can you run two same on two ports? No, right? Consider that inside the container here, as you're saying it, inside the container, I have Nginx here. I see your request is that you're saying the Tomcat is also available here. That is what you're saying. Now, in this case, Tomcat will be running on the same port number. This is not possible. Let's say that Tomcat is running on 8080, correct? This is what it is you do it. In this case, I'll map 80 to the 32775 and 8080 to a different port number on my Docker host again, right? This is what you do. You can do this one, 32554, something like that. So this is what you can do it. And on your Docker host, you need to access each individual port number that will go to the specific process inside the container, right? So this is how you can do it. This is achievable, but it is not recommended to do it. Okay. Right. So this is what I do it. Now we understood, team, how to access an application that is running inside the container. So in simple words, we understood how to create containers in two different ways, which is interactive and detached mode. And we understood why and where we create them, right? And second thing is that we understood about the container lifecycle with the various Docker commands, complete Docker container commands that we see it. Now, after that, we also understood how do you access an application running inside the container context. Even though different application in one container, port numbers are different. Even though different application in one container, port numbers are different. Of course, that's how it should be, right? It's a different application, it must be a different port number. Different server, right? Like Nginx is a different one, Tomcat is a different one. They are different servers for which you will always have a different port numbers. Okay. That's correct. Okay. Right, so let's move on, team, and try to understand about the next one, right? Next one is about how do I prepare my Docker images in simple words, right? I'll be showing you a quick way, team, again. So let's try to understand how do I create my own Docker image, correct? That is what you must understand. That is way, team, again. There are two ways, again, we have it. So how to create our own Docker images, okay? In browser, you have map public or private. It is a public IP address always, Sujata, because I'm accessing the servers over the internet. It must be a public IP always. Two ways again. One thing is called as your manual process. Second thing is called as your automated process, right? Now these are the two different ways, team, that I can do it. Now this is also known as creating, right? Creating a Docker image from container changes, right? This is what the process we have it. Now what I'll do is that simply run a container, right, in run a container in what? Detached mode, or interactive mode. Interactive mode. Make changes inside container, right? Simple that. Come out of container, right? And then commit the container changes. Commit the container changes, right? To prepare a new image, or to create a new image, I call it. Create a new image, we call it. Now this is how you must understand that there are 4 steps here. Creating the container, creating an image from the, creating Docker image from the container changes, we call it. This is a manual process team, that's what we say it. So run a container in interactive mode, we know that how to run an interactive mode. Make changes inside the container, that's great. And come out of container, and then commit the container changes to create a new image accordingly. So here team, I'll repeat the same process here, please look into this. Okay, Docker container ps. I'll remove these containers team. Docker container rm, I can do it, and give the container IDs. I'm just removing these ones, so let's have a clear picture of everything. Okay, -f, I'm forgetting it. Right, so I'm removed all the containers. Now if I go on do something Docker container ps-a, now I do not see anything. Now team, consider that the same image I'm running it, Docker image ls, right? Let me run the container team from an Nginx image again. Docker, right? Docker run, I do it, -it. I said run in an interactive mode, so there is no container. So I'll create a new container from the Nginx image again. Docker run -it, right? Docker run -it. I'll give the image name, which is Nginx, right? And I'll give the bash. So I'll get inside the container team. I'll create and I get inside the container. So you see that now I'm inside the container here. Now, once we are inside the container, make the changes, whatever the changes that you want to do it. Let's say that I want to make the changes for the default Nginx address, right? Let's say that es-ef grep jet, Nginx, I see it. Okay, ps command not found, since it is the minimal OS library. Let's see that ngi nx, I'll do it, status. Okay, what is that Nginx ticket? Okay, how do I check the status of this one team? I really am not going to get. Okay, signal terminal -v and do what? Okay, this is not giving me, or let's say that here service Nginx status maybe. Okay, I see that my Nginx server is running team. Nginx server is successfully running inside this one. Let it run it, that's okay. Now let me change the default configuration team or default website that we have deployed, or this is the default one, right? Let's say that is where under user share Nginx HTML. Now I'll go here. There is a default Nginx index.html. If I look at it, cat index.html. Now this is the page team that you are seeing on the browser, which is a welcome to Nginx page, like you were seeing it on the console. Now let me modify this basically vi index.html. Now I say that the vi command is not found. What I can do is that I'll install a vi editor for my own changes, right? Say that apt get update. It is a Debian operating system team that we already see it, so it will run your apt get commands easily. Now let's say that apt get install -y vim, right? I'm just modifying this one team. Now I did install my vi editor, that's great. Now I'll do that vi index.html. Now I'll modify the context here, right? Whatever I'm seeing it earlier, which is welcome to Nginx, let me modify that, right? So let's say that here, I'll say my first Docker image, right? I'm just saying that this is the text I want to see it on the browser. That is what all I'm doing it, right? Let's see this one. I'll save. So instead of welcome to Nginx, I'm modifying the content. Consider that you are doing your own changes inside the container. right? Just to validate team, I'll just do that curl localhost, right? 80, try to do it. Okay, I can see the response is coming out from my Nginx, right? I'm just sending the local team, just validating that the image which I did it is coming up here, which means that my changes are published with my Nginx server. That's great. Now consider this one team. This is what we did it here, correct? Just for a no graphical view, what we have done it so far, correct? So here team, we had Nginx, right? Image. Nginx image, the default image has it, default Nginx image, we had it. Now within which I had the default Nginx and plus the OS library, which I had it something here. Now after this, what I did is that I ran it as a container. Now when I ran it as a container, right? When I ran it as a container, it has its own changes, right? So let's say that it will get the same content here, Nginx and the OS library. Now here, this is what we had it. The default OS library had it. I added something called as vEditor, right? Now I also modified, right? I also modified the default, right? Modified index.html. This is what I did it inside the container, right? This is my Nginx container. This is what I did it. Let's say that here we ran it, right? Run it, this becomes a container. So we did changes inside the container here. Now once you did the changes inside the container team, you did whatever you wanted. That's great. Now let's come out of a container here using control PQ and came back to my Docker host. Now if I see this, basically Docker container PS, right? Now you see that your container is running. Now team, consider that the changes are present inside this container. Your image has the default content. Now your container has the image content plus the changes you did it accordingly. Now in this one, if I remove the container, right, if I do a Docker container RM, the changes that you did it so far will be lost, right? Now I do not want that to happen, but I want to preserve the changes completely or save it permanently on my system. Now that is where team, we say that we can commit the container changes that would prepare my new image accordingly, right? See that here, again, I'm doing it here. If you see this Docker image ls, now you see that there is something here. You do what? Apart from this one team, consider that right now I'll do Docker commit, right? -m, you can give a standard message like git message only, right? A modified index.html, right? Whatever you did it, or I say that deployed my app, whatever it is you say. There's a random message name, you can put anything there. Now, which container are we committing, right? You need to choose the container ID because this is where I have the changes. I'll give this one and I'll put a new image name. This is my Nginx right now. You can give any name, the new image that is going to be created. These are my Nginx server with version 1. I'm creating it. That is what all you need to run it here. Now you can see that Docker image ls. Now in this case, you will see that my Nginx image got created. Try to understand team, your default Nginx image had around 133 MB. Now since you installed a vEditor, you did update basically. Now this has grown the size of image accordingly, right? Now this is my new image team, which is just created. Now in this case, I can simply remove the container. Now once I prepare the image, I'll remove the container. Let's say that Docker container, right? RM, I'll do the container ID. So this is how you can simply do that. Done. Okay, great. If I'll do it, this is what you, so you removed the container, which means if I go and do the container again, right? PS, it will not be there. But since I have the image prepared, now this image can be run as a container again. As long as I have an image, I can run it as a containers. Docker run, I will run directly in a detached mode, -d, -p. I'll just do this one, right? My Nginx v1. Now when I run this one, it will create a container again for me. The Docker container, right? PS, if I do it, now it is not running successfully. And let's see that why it is not running, right? Here we go, right? It says that there is something, it is going bad here, which is not running or which is not able to create the Nginx process accordingly, right? So here it is team, it is running it, but it is not doing something. Why? Right? So let's do this one. Why not? I'll create it again team. Let's see that. I'll run it in an interactive mode if I want it. Docker, this one. You can do -p also, that's fine. Bash, I'll do it. Now I'm running a container team. This is went inside. Now I'll do a control PQ. Now it is a Docker PS. You see that the container is running it. Is it mapping a port number? Is it running the container or not? We'll see it again, right? Let's say that curl a local host. I'm just wherever this one it also team 32777. I do it. It says that empty reply from the server, which means that team the Nginx is not getting started inside the container. We would need to validate why it is not getting started, right? So let's say that here I'll get inside the container docker container exec, right, -it, and I give the container. It is because team the container is not starting the process or Nginx process. Let's validate here service Nginx, right, status. It says that it is not running. Basically that's the reason your server is not responding. Now consider that why it is not running. Consider if I go here, so there is a script which is this one, docker entry point ssh cat, this one you do it. Now this is writing team, but why it is not executing again? This might have made something wrong. Means our image process is getting failed because of some issue. We will see that why. Okay, so we can check the logs. Maybe that's what I can see it. We just modified, right? That's all we did. Nothing else apart from that. So anyway, team, I think that let me start the Nginx here. We'll see that why again. We'll start that, but you just understand the process of image creation. I'll see that why the image process is getting. I mean, the service is not getting started. But now I'll start it manually. All right, service Nginx status. Okay, service Nginx start. I'll do it. Now let's go and do the status. Now see that my Nginx is running. In this case, if my Nginx is running inside the container, what was the port number? Which is 32777, right? So I'll access here, which is this one. Now you should see that my first Docker image. Now consider that one team. I'll give you the resolution for that why it was not starting, but that's okay. Here it is team. You can see that we have created our first Docker image successfully. I ran the container from it, but the container is not starting the process for some reason. I'll troubleshoot and let you know why it was not starting it. But our understanding here is that team, you just need to understand about how I'm preparing the container. The image from the container changes accordingly, right? Now this is what all I'm doing it. Now whenever I do here, whenever I make the changes, I will commit the changes, right? You do commit. Now this becomes your new image with all the content. My Nginx v1, this will always have your index.html, the new content plus the old one, which is Nginx server plus the OS library, and everything will be available. Okay. Now this is the process of image creation team. This is the process of image creation that you must have an idea. Now, if you have any question in this image creation process, let me know. We can discuss it again accordingly. Yes. Does anybody have any question on the image creation process, the manual process? Tag name with the new image is mandatory. It is recommended, Pandit, because you create multiple images whenever you make a code change. Let's say that continuously developer is committing the code. Whenever there is a new code, every time you need to generate a new WAR file, a new WAR file will be have to be packaged into a new image. So it is recommended that you must give the tag. The versioning need to be done for the image. That's why the tag is nothing but the version number of your image. Okay. Good. Or any questions? Yes, team, any other question? No. Okay. Great. So great team. So I hope you all got now with a manual process. Now this is the manual process team. For example, again, I'll take the other one, which is going to be the automated process. Okay. I'll come out of this container. That's okay. Right. So let it be. Now here team, how do I go for the next process, which is your automated process, right? Now, when you run the automated process team, when you run the automated process, here team, we need to write a script, right? So we will write a script, right? Whenever you think about automation, it must be a script always. We will write a script called Docker file. I'm not sure if you heard about a Docker file earlier. Now the Docker file is a script team to create a certain Docker images of your choice with an automated fashion, we call it. Now, how do I write this Docker file, right? How to write Docker file, right? Now here team, try to understand that Docker gives a predefined Docker instruction. Docker instruction, you can call it as instructions. We call it instructions, predefined instruction, right? Now with which I'll be able to write this one. Docker gives a predefined instruction to write a Docker file. Now consider this one team, the same thing again, right? How would I write is that, let's say that inside, first of all team, I need some base image from where I can start my changes, like you have an operating system and start making your changes accordingly, right? Now that is where team, you must do the same thing here, correct? So you must have a base image such like I started from the Nginx and started making the changes. So let me do the same thing here again. Let's say that I'll do a Nginx is a base image. The same thing above which I did it, I'll do the same thing here as well. Now Nginx is a base image, I'll take it. Now after that, I need to run it as a container, and inside the container, we ran a couple of things, right? We ran something called as apt get update. We also ran something called as apt get install -y vim. Something, this is what we ran it inside the container. Apart from that one, you also started making a change with a vi command. Since it is an automated process team, I cannot open it in interactive mode there. What I'll do is that I'll just say that echo my, I call it as my second Docker image. This is what I do it. Now I'll put it this one onto my file again, which is user share nginx nginx/html. This is what all I'm doing it. Right under that you have index.html. This is what all I'm doing. I'm replacing the entire content. You don't need a maintainer mandatory. Maintainer is not mandatory at all. Just that if you want to mention your name that you are creating your image, maintainer you can do it. Otherwise, it is not necessary. But let's say that team, these are the manual instruction which I ran it. But how do I pass these things to the Docker, right? Because Docker has to run this one right now. I'm not going to run it, right? I will not be running it. But how do I give a Docker to choose the base image, right? And it will start a container from it. Now inside the container, it has to run this command accordingly. Now this is where we come with a Docker file instruction, which are given by the Docker. Like your Ansible has given something called as host, task, and everything. We did it. Similarly, Docker also given something predefined instructions, which are also known as a Docker file directives, which is where I use a statement called as from. Now the from is a statement team which sets a base image always from where you will start your changes again, right? That's how you do it. Now once I took it, like when I say from Nginx, okay, Docker understands I need to take this as a base image from which I need to start making changes. So it will take this one, it will start a container, it will copy, it will start running these container commands. But how Docker going to run again? So I'll give another instruction of Docker, which is run, right? Run this command. Now I want to run this command one at a time. Run, right? Docker has to run all these commands. So this instruction is that run. That's all you do it. Okay, so if you would like to maintain the maintainer, you can do that also. That's not mandatory. Now these are all the things team that you did it, or you can do it also accordingly. If you would like to change anything else again, you start keeping more container commands also. That is even possible. But this is the simplest one which I'm doing it right now. So this is the simplest one which I'm doing it right now. Let's go ahead and start putting this one into the file. Right, I'll take this one, I'll go here, I'll say vi docker file, whatever I want to create it, and I put it here. Okay, let me remove the spaces. It must be starting at 0. That's all, team. I'm doing it. So I just do this one. Let's say that I do this one. Now I need to execute this Docker file, team. So how do I execute this Docker file? Is that using a Docker build command, right? No file extension required here. No file extensions for the Docker file at all. Okay, no extensions are required. It's just a plain text file without any extension. Okay, so Docker build, I need to provide the file name with a -f parameter. Again, I provide the file name which I have instructions in it, right, which is a Docker file for me. Now I need to give a new Docker image, means once I run this one, what is the new image name should be. That is where we give something called as -t, right? -t is the tagging we call it. That is where you see that my Nginx only, but this is my version 2, right? Automated process, I call it, right? Now this is what I just said. Now after that, team, you must give a context called as dot, which is mandatory again. So this is like a current file system reference where it will try to prepare the image and try to place the image on your current file system reference accordingly. Now let's say that I'm just going to run this one. Now you can see that it is trying to do whatever I did it manually. It is trying to do the same thing in automated fashion for you, right? Done. So in a matter of seconds, I see that my Docker image is created. Docker image ls. I see that the second image is available right now, which is my Nginx v2 auto and so on, so right, which is also the same size team because we did exactly the same changes. So it will see the same size accordingly. Let's say that a Docker run. If I see this one -p my Nginx v2 auto, whatever the tag that you give it, you must give it here. So let's see that this is what. If it's going to run, it is fantastic. If it's not, then we will see why it is not running again. Docker container ps, I do it. Now you see that my container is successfully running here, which is my Nginx auto, right? The automated process is running successfully. Now if I see this 32778, now I must see my second image and put, right? Now you can see that, team, it is my second image because I replaced everything. You see the response called as my second Docker image, correct? Now this is how, team, you must understand, right? You must understand how do I prepare a Docker image with a manual process and with an automated process also accordingly. Okay, so are we clear now? How do we prepare the Docker images, or do you have any question regards to anything? Anybody have any question? Okay, so if you're all good, team, I'll show you one more Docker file. Hyphen if it's a file tool, which file I'm going to use it. Yes, Vinay, tell me what questions you have. We are here to discuss. Hyphen F is a file tool. That is what it is. If you see this Docker file, right? Where is this Docker file? I'm going to show another automation. I will be showing that, Pandit, definitely. Just give me a second. Okay. So what is the difference between a shell script and does your shell script can build a Docker image? Do you think that? See, whenever you want to build a Docker image, what command do you use? Docker command or a shell command you use it? So here, who is running the instruction basically? Whatever the instruction that I kept it in my Docker file, try to understand it. Who is running that one, right? Now, when a Docker command is running this file, the Docker should understand what instruction you're giving it, right? Now that is the reason you have the from statement. First of all, a from or a run. These are the Docker understandable commands or Docker understandable syntax, which Docker only can understand it, right? If I put this into a shell script and run a shell script, dot slash and shell script, it does not work for me, right? Shell script does not understand what is from. This shell script does not understand what is run, so it cannot understand it. So that's the reason this is called as a Docker file, which only Docker can read it and Docker can understand it. Docker will try to build using these instructions. But in order to install or uninstall something, you must have a shell command only. You are running the shell commands with a Docker instruction that is called as Docker file, right? If you want to directly reinstall it on a virtual machine, you can directly use a shell command. But we are trying to install inside a Docker container. That's the reason we need a Docker instruction here that is understanding. Okay. So let me show you another example team. Maybe you will understand it in a little better way, right? So let's say that Nginx D file, I call it some file, whatever the file name you want to give it to. Now here, look at this one and tell me what exactly you're understanding. Look at this one and tell me what do you understand from this. In a previous image team, a previous one, we are directly taking an Nginx image where you have an OS library plus an Nginx is already installed it, and there you are trying to make just the HTML change. That was the previous image. Now here I'm installing from the scratch. So I'm taking my Ubuntu image, just like you have a Ubuntu virtual machine. On top of it, you install it, a server like this, right? Here the base image is Ubuntu. That's absolutely right, Atul. Now here I'm taking the plain OS image team where you do not have anything. In the previous case, there was already an OS, there was already an Nginx is installed in it, right? On top of it, you're just making the modifications. That's all you're doing it, right? Now in this case team, we are actually installing our own stuff, right? You're taking the basic Ubuntu image. On top of it, you're running an update. Now I'm installing my Nginx here. This is what I'm doing it. I'm also making some other changes here, or let's say that, right? I'll say that run, right? Echo my another image, I call it my another image, I call it, right? And where I need to put this one, you may say that again, put it this one, let's say var www html index.html. That's what I do it. I hope that is the right path, otherwise it will not work. Let's say that I'm creating a file, creating a folder, creating that. You can do any change that you want to do, team. These are not mandatory. I just have written to be sure that you can create directories, you can create something. Everything you want to do, you can do it accordingly, right? That's what you're doing, team. And apart from that one, you can also copy a file if you want it from the local host. Let's say that I'll do a copy statement. So when I do a copy, narration.txt, I want to copy to the temp folder, right? This narration.txt team should be available on the Docker host. The copy statement will copy something from the Docker host to the container accordingly. That's what we do. Now the here team expose statement is mandatory again. Whenever you building your own stuff, whenever you installing your own stuff, basically try to understand what is the importance of expose, correct? Now think about it, team. Whenever we run the Nginx container in a detached mode, the Nginx image as a Nginx image as a container in detached mode, did we start the Nginx or did we start the container? What did we start? Everybody, what did we start? Yes. Yes, team, I'm asking you guys. Did we start the container or did we start the Nginx process? Did we start the Nginx process? Did you run service Nginx status? Service Nginx status? Start command? No, right? We haven't ran that command, right? We haven't started an Nginx process team. We just started the container only. So internally, the container started the Nginx process. How did it started? Because there was a default command set such as this one, right? The cmd statement team here, I'm setting up a default process, right? Which means that whenever somebody runs this image as a default detached container, now this is the default command to run it. Like whenever your system boots up team, you set up a boot up process, right? As part of the system boot up, if you want to set the system services, that will be started automatically. The similar to that one, whenever somebody starts this image as a container, there should be a default process started. That default process is your Nginx. So for which I'm setting up, this is like registering your system service. Think about this is the command theme which is given by the Nginx to start my Nginx process manually in a foreground process. So that is the reason I'm using this one. Okay, this is about setting up a default command. That's okay. Now, what about expose 80? Correct. Now consider the scenario again here. Whenever we run a docker run -d capital P, right, and Nginx I set it. Now you saw that there was a port number mapped here, right? There was a port number mapping here, which is 32775, which is redirected to the 80. Did I say that to redirect to 80? Did I ask any way to redirect to 80 number? Why did it redirect it to 80 only? Why not 81? Why not 90? Why not 8080? Something like that. Why did it redirected to the 80 port number only? Correct. Now that is where team this comes up. Means that when somebody prepares the image, basically they normally expose it. So this expose will help Docker to identify that okay, by default this image would run a port number called as 80. So I would have to map a host port number into the 80 of the container. That is what the understanding Docker takes it. If you don't expose it, Docker cannot understand how to map, or hyphen capital P does not works. Okay, that is what you do it. So here a daemon of is something, right? How do you run a process? Basically, what are the different ways to run a process? For example, container itself, right? We ran the container in two different ways, which is one is an interactive, which is a foreground process, I call it. One is in a detached mode, one is in a background process. Correct? Yes, Atul. We ran the container in two different formats. One is in the foreground where you're interacting with the container. One was in a detached mode, which is in the background process. Now, this daemon of for the Nginx is that inside the container, the Nginx process is running in the foreground process. Okay, foreground mode means a process always can be started in two different modes. One is foreground mode, one is in the background mode. Okay. Similarly, inside the container, I want to start this Nginx in a foreground mode. So I'm saying that a daemon of means that one, don't run as a detached mode or a daemon mode, right? You run it in the foreground mode. That is what the meaning of it. Okay. That's why I mentioned it. It is necessary that it is recommended, or Docker says that inside the Docker container, the processes should be running on the interactive mode, or so that they can be seen accordingly for it. So that's the understanding that you need to have it. That's okay. This command is it's given by the Docker Nginx itself, so you don't need to remember either. That will be permanent for it accordingly. Okay, now this is what the understanding team that you just need to have it. So let's look at it. Let me create this one team, narrate.txt. Let me see this one and we'll see what. Let's say that touch narrate.txt. The file must be present. So let's say that here docker build -f, which is nginx docker file -t new image, I call it v1, whatever you do it, and give the dot where the file is exists like that. You can see this one. Now this is how team, you can see that it is Ubuntu 18.04 is not present, so it is going to pull it. It will start doing it. Why we have to run the process inside the container foreground mode? Okay, when you do a docker logs command or docker container logs, Pandit, think that how are they able to show it up on the screen for you, right? If a docker logs, if you want to see the docker logs command or docker logs to be working, if a process writes inside the container in a foreground mode, whatever the written in a foreground mode of the container, that will be shown in the docker logs command. That is the reason they say that, you have to run it so that I can work with the docker logs command without going inside the container again. Okay. Okay, so great. Right. Now you see that team, my Nginx image is set. The new one, docker image ls, I'll do it. Now is that there is a new image is built. Now I'll do something, docker run -d capital P new image v1. I'll do it. I hope this will be running it. Docker container, right? PS. Yes, my image is successfully running as a container now. As you can see that this is the default command it is executing, which is user has been something something, whatever the command. This was the default command somebody set for this image, somebody who prepared that image. Now here team, this is what I see it now, 32779 I call it, right? I'll see this 32779. I can see that my another image that is there, right? So I'm able to prepare multiple Docker images team like this. We will be able to prepare as many images as you wanted. And for the understanding is that whenever you build a war file, for each war file, you must build a Docker image also. That's how you will be able to deliver an application into the production, whatever the way we want it again. Okay. So hope everybody is clear with our team, right? So I've shown you multiple Docker images that we did it right now. Now the next level team here, we understood now how to run the containers, right? How to build the Docker images, right? Now you may see later team how to upload this into the Docker hub also. We can even do that, correct? That can be done. Now here team, if you want to upload your Docker images to the Docker hub, right? You may go to the Docker hub and create an account, right? You may go to the Docker hub and create your Docker hub. Like my account here is Learn DevOps again, right? I see that I have a Docker hub account. If you want to upload this Docker image to the Docker hub, because this is a public repository just like your GitHub, you can even upload your Docker images to the Docker hub and show them accordingly. Okay, so I'll do the Learn DevOps. Oops. Right, I'm able to log in. As you can see it, you can also create a Docker Hub account team and start running this one. That is a tag, Atul. The version that your materials, the way you want to write it, you write your own stuff. Okay, there is no restriction there. Whatever the way you want to write it, this is like image version 1, version 2, version 3. I said whatever the version number I wanted, I assign it accordingly. That's your choice. So this is how team you can create basically a Docker account, and then under that you can create a repository here. Create a repository. Let's say that this is my hello app, something repository name is, I'm just creating it as hello app. Now make it public team. Docker Hub gives you the public repositories for free. Private is chargeable. So you must be public and say created. Now when you say created, basically it is going to create your repository. Is it created? I can see that my hello app repository is created, right? Now, if I want to upload a Docker image to this repository, you must rename your Docker image with this name team. Then only it can upload it here. Try to understand that I must rename my local image with my repository of the Docker hub. Then only I'll be able to upload it accordingly, right? It says that Docker push something learn DevOps hello app and the tag name here, right? So what I'll do is that here, Docker image ls, right? Now, first thing is that team rename your image with the Docker Hub account name. Then only this will be able to push to the Docker Hub. Let's see that here, Docker tag is the name here to rename a container, to rename a Docker image, I'm sorry. See that this is the image I'm renaming it, which is v2 auto something, right? Whatever the image that you did it. Now this one, I want to rename it to my Docker Hub repository name, right? Which is learn DevOps / hello app. This is what I do, right? What is the repository name? Hello app. Now let's say that I give you a tag name again, the same tag name. If I want to do it, you give it. Consider that this is my hello application. Now your hello application v2, you can just give v2 also, whatever the way you want to rename it, you rename it. When I do this one team, you will be finding that particular tag again here like this, right? Now, once after I do this, you must log in from the local to the Docker Hub account, which is a Docker login command. Do it. It will ask you the username, the same credentials that you put it on the Docker Hub, which is, all right, learn a DevOps. I log in. Oops, the username password is wrong. Now you can see that I got a login succeeded message, right? First thing is that you rename the image with your own version or with your own this one. Now second thing is that you need to log in from the log command line to the Docker Hub. Then you do something called as Docker push, and do this one. V2, this is what all I do it. Then this will be uploaded to your Docker Hub account automatically. Okay. Once this is pushed, we can see that the image is available here. You can see that a v2 tag is just pushed a few seconds ago, right? Now, likewise, team, you can keep on uploading the Docker images the way you want to do it. Okay. So you must rename the Docker image, or you created a copy of it with another name. It is just alias name, but it is not even a copy of it. It's just the alias name. We do it like you have a nickname and you have a official name in the pages, right? You have this one. Think that this is my original image, which has an image ID, this one. Look at the image ID. This is exactly the same thing, right? So that a single image, you have image is one only, but you have multiple names to allocate it to it, like alias names or different names for the same Docker image. That's all about it. Okay. Right. That's all you do it. Now this is how team you could upload a Docker image to the Docker Hub also. That's how you can do it. Okay, great. So with this team, I'll stop with the Docker containers and Docker images. That's good, right? We understood the basics of the Docker 100%. Now after this one team, we need to understand one more concept called as container orchestration. We'll be discussing about it. But before we do that, let's go for a 5 minutes break. We'll come back and we'll discuss about it. What do you guys say? Let's go for a break for 5 minutes. From Docker Hub, can we pull the image? Of course, right? From where I'm getting the images, Atul, from the day one, right? Yesterday also we pulled it. Today also we're pulling it. We are always pulling from the Docker Hub only, right? For example, if I have my image, let's say that if your confusion is that, can I pull it from my own account? Of course, I'll be able to, right? Let's say that here, I'll go to my repository from my account, right? From the day one, we are always pulling from my account only. I mean, so that Docker Hub only. For example, py app, just to show you, right? So here it is, see all. You can pull this latest or v1 or v2, just pull it. So whenever you pull it, it is always referring to your Docker Hub only. Okay. Anyway, let's go for a break now. We'll come back and we'll discuss the rest after the break. Okay, so team, I'm also back. Hope everybody's also back as well. So let's think about the next solution team which we needed. We are going to work about the realistic production environment right now, right? Think about a realistic production environment team. How many servers do you have in your production? Yes, everybody. How many servers do you have in your production? Is it 1, 2, 10, maybe? At least more than one, right? Minimum two. Right, at least two or many or whatever it is, depends on the project size. You would have n number of servers. That depends on your project basically. Okay, now but at least you will have more than one. The reason behind that is that you want to maintain the high availability of your application. In case one of my virtual machine or a server fails, other server would still serve my application basically. So here also team, we need to run multiple containers first of all, right? The question here is that how to run multiple containers. But if I containerize my application, which means one image is something, so if I want to maintain the high availability of that application, I must run multiple containers from the same application, right? That is for the understanding. Now how to run multiple containers from a single image, right? That is there into multiple servers. That is a question team. That is a question basically you must answer this one now. So how to run multiple containers from single image into multiple servers, right? With a single command, with a single command again, right? Means if I issue a command like say that I want 10 containers, that must issue or that must create 10 containers for me. That's how the understanding is should be here, right? So here team, so how do I do that is something very basic we need to understand, because we are thinking about running our application in production environment. So if you want to run in a production like environment team, because containers are dynamic in nature, we already understood that containers have a dynamic IP address, containers have dynamic resources, containers have dynamic IDs or whatever it may be, container names, and everything is dynamic here. How do I manage this dynamic nature of the containers when we want to manage across n number of systems, right? So in order to manage team, we must need a good system basically which tells me or which manages this containers well. Now that is where we talk about something called as container orchestration, right? What do you mean by container orchestration is that basically, so it is going to help us with, right, helps us with running multiple containers, right? Multiple containers into multiple servers. That is the primary purpose of this one, right? The second option is that it helps, right, containers communicate with each other. Containers communicate across all the servers, right? But it's called as nothing but a networking that we need to build it. So container orchestration builds that. Simply we call it as networking for containers. We do it, right? This is how team also provides some kind of a scaling features. Scaling feature need to be there, or features we call it. Now along with that, it is also going to provide me a desired state feature. Desired states are required. What is desired state and everything, I'll talk about it, right? But let's understand this. The primary purpose is that we need to run multiple containers into multiple servers. So in a Docker Swarm team or a container orchestration, basically we need to create a cluster of Docker nodes, right? We say that we're going to create a container orchestration solution. So there are many container orchestration solutions. You have it in the market, out of which you have something called as Docker Swarm is the default with the Docker again, right? With the Docker that you installed it. Docker Swarm is a default one with which we will be able to do it, right? Now Docker Swarm is nothing but a cluster of Docker nodes, or we call it as Docker host, whatever you do it, right? Now this is the understanding team that you must have it. Now what is a cluster basically? If you understand again, a cluster is nothing but a group of, right, group of virtual machines, right? In our case we are taking virtual, so I'll see that a group of virtual machines or a servers you call it normally. What do you think? It is nothing but a group of virtual machines together, we call it as a cluster. So when I say group, it will be more than one always. Again, that's the understanding, right? So cluster is nothing but a group of virtual machines. In a cluster, I said cluster of Docker nodes, which are multiple virtual machines which have Docker installed are called as my virtual or a Docker Swarm cluster. That is what we do it. Now, Docker Swarm is nothing but a container orchestration solution which will help us. So, for example, here, first thing is that I'll be taking multiple virtual machines, virtual machine 1, virtual machine 2, and virtual machine 3. Whatever you do it accordingly, right? Now, after this one team, let's say that I need to create a cluster with these ones. First of all, I must install Docker on everyone. Let's say that this is my VM1, virtual machine 1, I call it. Now, this is my virtual machine 2, and this is my virtual machine 3. Must be there different virtual machines like this. You can have n number of virtual machines, like based on your project. Again, you may have based on your project capacity or project needs. All right. Now, apart from this one team, right, the machine should have a Docker installed already. Means a Docker and the OS. Means every virtual machine will have an operating system. On top of it, you must have a Docker installed accordingly. So this is what the basic need on every virtual machines that you're going to have it. Now, once you have these independent Docker nodes team or independent Docker host, if I want to group them, if I want to prepare a cluster, right, that is where you call it as Docker Swarm, right? So this is team, I will virtually group these servers. Now these servers becomes my Docker Swarm cluster. Now, in order to prepare a Docker Swarm cluster or a container orchestration solution team, you have right, a swarm is nothing but, right, you have, right, in a swarm we have at least one manager node, right? We call that one manager node, and you will have n number of n worker nodes, right? So manager node for administration activities, we do it, right? So manager node to, to manage the cluster members. We call it members are nothing but your worker nodes. Now the worker nodes are for running the application containers. Okay. Now this is the solution team that we have to do it so that it will be easy for me to manage, right? Cluster members and the containers, we call it, right? So manager will manage the cluster members, nothing but the worker nodes, right? We'll write simply, right? Instead of cluster, say that, you'll say that worker nodes, right? To manage the worker nodes and the containers running on them, we use a manage node, and then we have n number of worker nodes in the cluster. All the worker nodes are responsible for running the containers, right? That is what you do. Now, manager node also delegates team here. That is what it's going to do. Swarm is nothing but a combination of one manager at least, right? One manager at least, and n number of worker nodes you have it. So in this case, team, consider that one of the node I'll be electing it as manager node, and rest everybody here will be working as worker nodes. Worker node 1, worker node 2. Likewise, you may have n number of worker nodes in your cluster. That's your choice. Now, how do I create this manager node? Basically is that you just need to initialize the swarm. See that Docker swarm init, I'll do it. This will, or wherever you run this Docker swarm init, that will become a manager node. Now, in order to join a worker node to the manager, like it is like a team manager team, a team you have it, you have a team manager and team members, you have a team leader who is responsible for managing the team members. Along with that, he will also assign the work if he wants to do it, right? Now, this is like the same team. Now, these guys has to report. This guy, a worker node has to report to the manager. So I'll say that you are not the manager, but you are going to join the manager, or you're going to join the team of that manager. You will start reporting that. So we will run a command called as Docker swarm join, right? Every node that wants to be part of the cluster, every node that who wants to report to this manager, right, they will have to join the cluster. They will start reporting to the manager accordingly. Okay. Now this is the idea, team, that you must have it, right? This is the idea that you must have it about a container orchestration solution. Why do we need a container orchestration? Is that helps us with running multiple containers into multiple servers with single point of entry. Now helps us container communicate across all the servers, networking for containers, right? And scale the number of application containers, right? Now desired state will be there. So what is desired state? We'll be discussing about it accordingly. So Docker Swarm is the solution we're thinking about it. So Docker Swarm is nothing but a cluster of Docker node or Docker host. Cluster is nothing but a group of virtual machines or servers. We call it in general words. Now, a swarm is always a combination of one manager and n number of worker nodes will be part of it. So this is how you must prepare teams. So for which I think I have created multiple virtual machines on my AWS account. Consider the servers that are running here, which is manager, worker node 1 and a worker node 2, right? So these are the ones which I'm running it, right? So here team, once you have these ones, sorry. So consider that you have 3 nodes here. Now these are the ones which I logged in also. This is the node called as manager node. Now you have another node which is a worker node, right? This is my worker node that you can see it, worker node 1. Now this is my worker node 2, right? The only thing is that you just need to have Docker installed. So I'll say docker-v. I see the Docker is installed here as well, and installed here as well, since this is where we are working so far. Now, once I have this one team, I said like a Docker Swarm is an inbuilt feature of Docker itself. You do not need to install anything extra, right? Now that is where let's talk about it. Docker Swarm init. So as I told, wherever you want to initialize the manager node, now you do this one called as Docker Swarm init, right? You just run the command here. When you run this one, it will actually tell that a swarm is initialized, current node is now manager. That's what it tells you. Now it is also giving you an information called as to add a worker to this swarm, run the following command. Okay, I'll take this one, Docker swarm join the Tom token. This is your manager IP address, and manager port number is your 2377, because node wants to communicate with the manager. Manager should be listening on some port number. That is a default manager port number that gets enabled when you initialize the cluster. So let's say that here, I'll take this command, I'll go to the worker node, I'll run it here. This will clearly tells you that this node joined swarm as a worker. That is what you do it. Similarly, I run it here as well. Now you can see that we are now created virtually grouped multiple Docker nodes together. Now I call this as a Docker Swarm cluster. Okay. Now within this one team here, here I do it now. If I want to check from now onwards think that if I'm a client, basically I'm an external user. If I want to give you the task to you guys, let's say that you are team members, right? And you have a team manager and I'm the client, right? So I'm the client, you have a team manager, you are the team members. Can I directly talk to you? Can I directly talk to you? If I want to talk to you guys, I have to come through your manager, right? Means I'll give the work to the manager. Manager will delegate the work to the team members, right? That's what happens basically. So in this case also team, from now onwards, we can always interact with the manager, or we give the instruction to the manager. Think that you are a client, you are asking manager, hey manager, I want to create multiple containers, or let's say that 4 containers from my Nginx. That is what I want to do it. So manager takes the request. Okay, manager looks at it. Oh, manager is there. I will delegate it onto these worker nodes, which are part of my team. I'll delegate there. That is what the manager going to do it. So here team, first of all, whatever the commands that I'm running from now onwards, which will be working only on the manager node. Okay, say that Docker node ls we call it. When I say node team, which is who are all part of the cluster, listing the nodes. Now you can see that there are 3 nodes which I have it, right? There are 3 nodes I have it. Here it says that there is something called as host name, this one, and this is worker node 2. I believe this is my manager node. You can see that the leader status is available here. Now this is where you can see that the leader is nothing but your manager. Okay. Now consider that Docker node you can do it, right? Docker node inspect you can do it to know more about the Docker nodes. Just that I'll do this one, right? Now you can see that there is a lot of information about the node which manager knows about it. This manager will have the information about the team members always. Limited to that one, this manager node also has the information about my worker nodes. Let's say that here the role is worker. You can see that clearly. The role of this node is worker. Now there is a node, this node is available. and there is a CPU resources capacity of the node. The manager will be collecting all this information so that manager can delegate the work onto the worker nodes accordingly. That's all you do it, right? So this is about a team. You can understand about from then onwards team. Now, if I want to create a container, should I use a Docker run command here? Right. So if I want to create a container team, so far I taught you a command called as Docker run. But the Docker run will always create a single container from a single image team. That's all you need to understand. So Docker run command will create a single container from a given image or from a single image. That's what you do it. But here team, we want to create multiple containers from a single image in a single command again. Now that is way team, look at this. Let me see this Docker PS. Let me remove all these default containers team. This is the Docker container RM. I do it. I'm just removing the containers team, so we'll do it. Right, so let's say that here, right now, I do not have any containers running on the manager node. Here also, we do not have any containers running. And here also, I do not have any containers running. Now, the only thing is that we grouped these servers and we are going to control the worker nodes with my manager node, right? Let's say that here. Here team, if I want to create a containers in a cluster mode, I use a different command, which is called as Docker service. I say that Docker service create, right? Name of the service, let's say that my SVC. Now I can ask how many containers I wanted, which is also, let's say that replicas, we call it. Replicas is nothing but, let's say, I want 7 containers, right? Now the port number that you want to publish it, you may use -p 9080. Or let's say that I'll go for deploying something called as 80, which is Nginx image that I'm doing it. Now, what is the image name at the end you can give it? Just like you're replacing Docker run command with a Docker service create command, but the capability of Docker service create is that it is going to create a number of containers which I ask it. I just need to mention how many containers I wanted. 7 containers I'm requesting it. Now the another advantage here is that the Docker Swarm Manager will delegate these containers into all the worker nodes accordingly. Run this one, it will try to start it. Okay, multiple things, couple of them are started. Now these things, everything is getting started like this. 7 is the number of containers, Atul. That's what I'm saying. Number of containers that you want it. Can we have 2 or more manager over the same worker nodes? Yes, we can have it that, Pandit. That is possible. Now, if I see this Docker service ls, this one is called as your Docker service, where you see that I requested for 7 containers. Now I see that there are 7 containers got created. How would I know them? You can see that a Docker service ps, right? Give the service name, right? Just like you are doing the Docker container ps. Container is nothing but the number of containers running on the node. That's the Docker service ps. You see it. Look at this one team, right? There are 7 containers running right now. They are all running across different servers also. Let's say that worker node 2 is running to 3 containers, right? This node is running 2 containers and this node is running 2 containers for you. For example, if I want to see that on how many are running on my manager node, do a simple Docker container ps. You see that there are 2 containers running here, right? You do something here. Did I run any command here? No, right? But who deployed the container here? Did I run any command here? But who deployed the containers here? This is nothing but your manager team. That is the advantage of creating a cluster here. Now from now onwards team, in a production like scenario, if I want to run 100 containers, I will just give the instruction to the manager. Manager takes care of creating 100 containers across 100 servers automatically, but they must be all grouped together. That is called as creating a Docker Swarm cluster. Okay, Now once you have this one team, once you have this one, this is all you can do it. Now you can, the advantage here is that team, again, you can ask number of containers to increase, means scale up parameters. I can scale up my number of instances easily with that docker service scale, right? I do it. Now let's say that my svc is equals to, I want 14 containers. Is it going to add another 14 or is it going to total 14 team? What do you guys think? Earlier I said I want 7, so it is created 7. Now if I'm saying 14 here, will it create add another 14 or total 14? Okay, great. I see that Atul says add another 14. Not really, Atul. It is altogether 14 I wanted, which means that there are 7 already running. So it is going to add another 7 for me, right? 7 out of 14, now 13 out of 14. So altogether it will be 14, not another 14 here, okay? That's what you do. Now this one, you can see that team, how easy it is for me to create a number of containers from a single image. Now I'll be running these many containers easily, that too across multiple servers, which means that if one of my server goes down here, one of the virtual machine goes down, you will have a virtual machines running where your application is running successfully, and you should be able to access the application without any interruption in the service, right? This is the advantage of the Docker orchestration team or container orchestration solutions. They will automatically enable us with these features, so you will be able to do it. You can also scale down team if you wanted. Let's say that from I want to do it 5 only, which means that it will delete everything except 5 containers for me, right? Scale up, scale down becomes very easy for me. If I go and do this one, now I see only 5 containers running, right? So this is how team you could scale up and you could scale down automatically. Okay, so we have all these 14 in both the workers, right? It is workers plus manager also. This is a good manager here. He is a technical manager, so he's running on the manager node as well. Right now also, if you see this, worker node 2 has one container. I think the names are populated here wrong basically. Let's see the host name -i command here. I can see that this is 37, right? So the 37 is your manager basically. 37 is your manager. So manager is running 2 containers. Worker node 1 is running 2 containers, and the worker node 2 is running 1 container bundle. Okay. So here is a good technical manager. So manager is also taking the workload. Manager is also working along with the team members. That's all about it. So manager is also running the containers here, application containers. So you will be able to see that. That's one thing. So we understood about how to deploy a service, right? That is nothing but a service is nothing but a group of containers team. That's all you need to understand. Okay, a service is nothing but a group of containers. What is a service? What I'm creating here, a service, right? In a Docker Swarm, we create service. Service is nothing but a group of containers from a single image. Okay, so this is the definition of a service team. You are logically grouping them, right? I call this as my SVC something, and inside this a logical layer, you have multiple containers running of your same image, right? Which is in this case, I have my Nginx. This is how you need to understand team. This is logical group of containers from a single image is called as your service here. Okay. So how Docker Swarm manages the container creation in worker nodes, like worker node 2 has 3 and worker node 1 has 2, it equally dividing or totally randomly or following any log. So it is following the utilization basically. Usually Docker Swarm Manager follows that. It will check the resource utilization of the nodes. Okay, normally it follows that strategy. By default, before it deploys it, it will check that, okay, how many containers are already running there? Are the resources good? Like let's say that if the CPU is utilized at 70%, 60%, compare with worker node 1, which one is more compatible? Which one is more free? It is basically done on the based on the resource utilization capacity. Internally, Docker follows that automatically. So got it. So total containers across all the workers and manager is that. That's right. So this is how team you can understand about it. This is the advantage that you get it with the service creation. Now you can like Reem, You can create as many services as you want it. It's need not to be a single service here, right? You can create as many services. Docker service ls, right? I can create another service with that Docker service create hyphen hyphen name hello app something. I do it, right? And once after that, when it's done, let's say hyphen hyphen replicas. I'll do something called as 5 replicas or 10 replicas, whatever I wanted. Now hyphen p, I'll do it a port number that I want to map it, maybe some random port number, and the container will be having some port number. So this is a special application team, special Python application, which is there in my Docker Hub account. Sample py application, I call it a v1. This is a customized Python application team, not a Java application that we're building, not a web server that we've done it so far. It's a customized Python application which I built it and which I deployed it as a Docker image, which I published in the Docker Hub. I'm just downloading that. Now this Python application inside the container will be listening on 3000 port number, and I'm also mapping the 3000 my Docker host. Let's run this one. So it is going to download the image from the Docker Hub and it is going to pull the things accordingly, right? Good. So it is able to start it. Likewise, team, you could run multiple services running different applications, right? Multiple services having different applications can be run, checking on your resource capacity of the servers. It will allow to run the same command on worker nodes. No, these commands are manager specific. These commands cannot work on your worker nodes. Okay, Cesar, that is not a manager node. So these commands, Docker service create, Docker node, Docker service, whatever you do it, these are all manager specific commands only. Okay, you must be running them on manager nodes only. Now, right, so this is advantage team that you get it. Consider that. Now, along with our team right now, so the scale up and scale down, you saw it already. Now there is one more feature, I'll say it. We don't have to pull the image from hub this time. Why? It is pulling, right? It is automatically pulling it, Pandit. You don't need to say explicitly pull it. When you create a service, if it is available on your local Docker machine, it will automatically create a container. If it is not there, it will automatically pull that. Okay. Docker service command will pull it, right? Let's say the sample py app, which is pulling it, correct? Which is automatically pulls the image first of all, and it will start running it. Auto pull, correct? So what will happen if manager goes down? That's a good question, Rajan. In this case, basically you will lose the features, right? The scale up cannot be done. You cannot deploy the further applications. That is what the effect, immediate effect that you see it if a manager goes down. So in order to manage in real time, in a production like cluster, we know that we are heavily dependent on the manager here to perform any action in our cluster, right? So to avoid the failover of the manager, we will create fault tolerance, which means that we'll create multiple managers in the cluster, right? So a single cluster can have multiple managers. At least 3 managers should be there in the cluster. In case of one of the manager goes down, so another manager will take over the charge automatically. That is a realistic production environment that you would do it whenever you work about the container orchestration solutions in real time. But for our understanding, we created only one manager here. Okay. I hope that is clear for you, Rajan. Right. So this is what the realistic. So that's what you do. Right. This is how team you can understand about it. Right. Now consider this one team. The next feature, basically, how do you access an application running inside a container? How do you access an application running inside a container? Okay, Docker service ls that I do it. So Docker container port number, Docker PS. What is the port number you see under the ports column? Did we expose a port number for a container? Did you see any port number for container? Yes, no team. You do see no, right? Clear that. It's very clear that you don't see it. Docker PS, you see that there is no port that get exposed here now, but But team, this is a different strategy here because there are multiple containers running across multiple servers. I need a load balancer to forward the request into multiple backends, right? I hope you guys be aware of the concept called as load balancing. If I have multiple servers in the backend, multiple virtual machines running the same application, I would put a load balancer in the front, and I register my virtual machines on the load balancer so that the request comes to the load balancer, and the load balancer will balance the load across multiple virtual machines, or load balancer would forward the request into multiple backend virtual machines, right? But here team, try to understand, since the containers are dynamic, whenever you create a port number of the container, that is generated dynamically. Can I register my container port numbers in external load balancer? Do you think that container port numbers can be registered in the external load balancer? Is it possible? I can do it, not a problem, but does it be constant? If it is not constant, right? Whenever I create a new container, if it is always generating a new port number, how many times would you update your load balancer, right? So that's a problem basically, right? So that is where team Docker has come up with a concept called as service. Now consider that we exposed a port number, but that is called as a service port number, right? Now this service port number is redirecting to the container port number, obviously. This is the service that we created. The service is exposed, right? Now I can access the service port number team, but that will forward the request into all the backend containers. So consider that the service that you created is also acting as a load balancer, right? This is also acting as a load balancer for me automatically, right? It will also do this one. Let's see that here. I'll go for it, 3000, right? Now you should see an IP address here. You see that this is my version 1 application, and it is serving the container ID, which means that the request went into this container ID. I'm giving the URL to you all team. Try hitting this URL in your browsers if you are in front of the system, right? I gave you the URL in the chat window, questions window. Try to hit it on your browser window. Okay. See that what it is happening it. Do you see the same response whenever you hit it? Hit it multiple times team. Refresh the page one more time and you see what's happening. Why it is changing it? Which means that the request is actually going to a different containers. That's what is something. So the service is kind of a load balancer team here. The service that you created here, you exposed a service per your container, right? That is a 3000 port number, and you have this port number mapping to all the containers, right? So this is what you need to understand team. The service is acting as a load balancer for you, and it will forward the request into all the backends automatically. That is the responsibility of your load balancer or a service here again. It may go to the request to any backend, right? It is not one-to-one, one-to-many, right? One service to many containers in the behind. Okay. Right team, do you get the feature? This is another beautiful feature of the Docker Swarm team, so that you do not need to worry about it. Now I can simply map this Docker service port number where I can keep it constant, and I'll register it wherever I wanted. I can send the URL token, right? Now this is how team you can understand about how to work with Docker Swarm again. This is one of the beautiful feature within the Docker Swarm, which lets us access our application running across multiple servers, with a single point of entry for me, right? A single IP address, single port number. The request is forwarded to all the backend containers, no matter what where they are running team, no matter what where they are running. Look at this here. Look at the containers here team. Docker ps, I'll do it, or a Docker container ps, you do it, same thing. This is sample py app. The container ID here is this 98. Now here you see the container ID is 77625. This is also not there. Now here you see the container ID is bc. All right, Docker ps. There is a container ID here which is 01 and 6c3, right? Now this is the output, you see it here right now, 6c3, which means that the request went into the worker node 2 and it is responding accordingly. If I keep on hitting this one again, see this, which is went on to another node here, which is 77. The request went into here, right? I'll replace here again. Now you can see that this time it went into a different one. This is not here and not here, and the request went on to this container. So this is how team you would understand about how Docker Swarm will function and how Docker Swarm will help us deploy and manage my containers in a very efficient way than we expected to it. So are we clear with the Docker Swarm so far, team, or do you have any questions? How to create a Docker Swarm, how to deploy services in the Docker Swarm, right? How to understand about, or how do I work on the various things? Clear or any questions? So randomly it assigns the ID to multiple container. That's correct. Every container will have a unique ID automatically. If a worker is down, then it will reduce the container or not. That's a good question, Pandit. What will happen if one of the worker node goes down? So everybody has the same question here, right? The question here is that what happens if one of my worker node goes down? Will it maintain 5 containers? Try to understand that here. I asked to create a Docker service ls. I asked to create 5. I asked to create 5. It is saying that I am running 5 right now. What happens if this worker node goes down where the two containers are running, right? Let's do that, right? Consider that somebody logged in here and they removed the containers, right? Docker container ps, Docker container ps. You see that there are 2 containers running. Let's say that Docker container rm, Docker container rm -f. I'll remove all these 2 containers. Okay, sorry, this is the one. So I removed these 2 containers, team. Try to understand, right? They are gone. Now if I come back here, I'll do this. How many are we seeing it? 3 out of 5. I asked to create 5. There are only 3 running. That is what it is telling you, manager. After some time, what happened now? Why again 5 by 5? Why again 5 by 5, team, here? Try to understand why again 5 by 5, which is called as desired state feature, team, that I was talking about it again. Docker Swarm Manager has a capability of maintaining a desired state. The last feature I was talking about here, which is a desired state, creates again it. That's what the meaning here, team, means that a Docker Swarm Manager maintains a desired state, which means that while creating a service, basically, whatever the number that you ask, that is the desired state. Now, Docker Swarm Manager thinks that whenever something goes wrong with a container, it will replace it with a new container automatically so that it will always maintain the desired state for you. Manager will recreate it automatically. That's what happened, right? About a minute ago, correct? Now that is how, team, you can understand that this is another beautiful feature here. You can always guarantee your application availability and stability to the end user with this feature again, the Docker container. Scalability, stability, we call it, right? Availability and stability will become more stronger. Assigned to another running one. Now the Docker node was not gone here. It says that simply I deleted a container. Of course, in that case, team, if the Docker node itself is gone, like Imanshu is saying here, let's say that I'll say service, I'll stop the Docker engine itself, right? Service Docker stop means if I stop the Docker engine, team, Docker software, you cannot check anything here, right? Says that is the Docker daemon running. In this case, what happens again? Whatever the containers that were running on that node will be shifted over to the working worker nodes. See that this is all good here, still not there. But here if you see it, Docker PS, Now you can see that there are new things came up here automatically, which is 9 seconds ago, right? Now this is how, see that it will try to shift over to the working nodes also. Whenever something goes badly with a worker node, if the worker node is completely down, whatever the containers that were running on that worker node will be shifted over to the working worker nodes. Thus, you will again get the design state automatically. That is the understanding team that you must have it here. That's how you can understand about the Docker Swarm features, or a container orchestration feature, I call it, because any type of a container orchestrations will always provide these features. Docker Swarm is one of them. We have it. This is how you get the features team. So is everybody clear now? Himanshu and everybody, whatever the questions you had it. Any other questions you have it? This is the beauty of container orchestration. So service, service Docker start. Good till now? Okay, great. Great. So, I mean, this is about the Docker and Docker Swarm team that we wanted to cover, honestly. So we have covered the good things, but I would like to give you another, just a brief in theory only. We are not going to get into practical of that. But let's say that here we are going to understand about one another container orchestration, right? Which is again, we call it as Kubernetes. Have you heard about Kubernetes anywhere? Have you guys heard about Kubernetes technology? Yes. Yes. What is Kubernetes? What is Kubernetes? Because Kubernetes is the hot technology in the market right now, team. If you ask about, 50 people, there are 40 people who are looking for Kubernetes technology. Or most of the organizations are trying to implement the Kubernetes technology. Or why it is this one? Creation of pods. What is a pod, Atul? What is a pod? I think it's a cluster management. Okay. Okay. Smallest executable entity is pod. What you are executing it is, Rajan. What is smallest executable entity? What are you running? Good. Why I'm running a pod if I can run a Docker container? Again, so I don't want to get into the details, of course. Whatever you're saying is right, but you must have an idea about it, why we are doing it or why Kubernetes does it that way. Okay, multiple containers. Okay, why would I run multiple containers in a pod? In a Kubernetes, it is recommended that you need to create multiple pods. Let's say if I want to run 10 instances of my application, I create 10 pods, but not 10 containers in a single pod. Okay, Kubernetes is a portable, extensible, open source platform for managing containerized workloads and services. Okay, auto scaling, automating computing application. I can get that. I understood that, Pandit. You don't need to see me that. I see the definition wise, it's clearly automating computing application. Okay, okay, fine team, whatever it is, leave it, okay. Think that Kubernetes is another container orchestrator. Okay, instead of a Docker Swarm, I can use Kubernetes instead. Like you have Android and Apple, which one do you want to use it? It's your choice, right? Whatever the way. Let's say that I have OnePlus or LG or iPhone or a Samsung. Which one do you choose it? Whichever is the best, right? What should you go for? Let's say that, think that when you think about containerization team, Docker is the one which talk it. So with Docker, we always create containers. Okay, means containerize an application. We prepare a Docker images first. Now, if you think about running these images as containers in a clustered environment, like in a production like environment, we need multiple worker nodes. We need a concept of manager worker nodes to manage the containers across n number of servers. In order to maintain or manage their dynamic nature, we created a Docker Swarm. We saw clearly that Docker Swarm is providing me the feature of running multiple containers into multiple servers, help containers to communicate across all this one, scale containers, desired state, whatever it is, right? These are all the features because of the container orchestration solution. Okay, now this is what it is, team, a Docker Swarm, how it is working it. Now what exactly the difference between a Docker Swarm and a Kubernetes, right? If you try to understand, team, right, it is the same thing basically, but with a different approach. Okay, so if you want me to compare both of them, team, consider that it will have the same concept. Consider that this is your Docker Swarm, right? We created a Docker Swarm like this, right? So we installed a Docker and we put a Docker Swarm and whatever you did, this is very simple one. Now Kubernetes is also another container orchestration team, right? Kubernetes is also another container orchestration solution. The concept remains same thing because it's a container orchestration. You have one manager, n number of worker nodes again, right? But team, try to understand that Kubernetes is just a container management solution or container orchestration solution. It cannot create container. It cannot run the container. It just manages the containers basically, right? So in order to create or in order to run the containers, I still need Docker. Okay. Here also, team, Docker is the one which is actually using the containers or creating the containers. Docker Swarm is again a management layer, which is just managing the containers. So it is able to deploy the containers, scale the containers, desired state. It is just like a management layer. Docker Swarm is also management layer. Just like that, Kubernetes is also management layer on top of a Docker. Okay, so without Docker, again, there is no Kubernetes. Okay, so in Kubernetes also you will have the same thing. The Docker must be installed first of all, but in order to create a Docker Swarm, you just did Docker Swarm in it because it is an internal feature of the Docker itself. So you don't need to install anything. But let's say that here, if I want to create a Kubernetes cluster, we use something called as kubeadm and kubelet are the tools. Okay, now this becomes the master node or manager node. Again, the same concept, worker node 1, worker node 1, worker node 2, whatever you want to do it, you do it. Okay, this is how you start creating it. Now these tools, team, you must install across all the worker nodes also, kubeadm, kubelet, whatever it is. These are the tools basically which will be managing the clusters accordingly, right? Now when I say here kubeadm, right, kubeadm is a tool. Like how do I prepare a cluster? Here I did Docker Swarm in it, so that become a master node or a manager node. Here, how do I initialize the master? Do I do a Docker Swarm in it? No, right? I do not want to do the Docker Swarm. Instead, I want Kubernetes. So Kubernetes is nothing but your kubeadm here. I'll do that something called as kubeadm init. So this becomes the master node. Similarly, I'll do something here called as kubeadm join, right? The same way you did it, you join the worker nodes again to the master node. That's all you're going to do it. So technically, team, they are same, right? Working nature of them is same thing, but except that the implementation is a little bit different, right? Now how your Kubernetes master can talk to worker node is that the kubelet team, a kubelet is an agent here. Kubelet, right, is an agent, right, is an agent that is responsible, right, for master and worker node communications. That is what I call it. So this is what it is, team. You can understand about it. So this is what it is, team. The kubelet is responsible, means that whenever the master node is communicating with the worker node, master node communicates to the kubelet process running on the worker node. So master or whatever the status of the worker node will be reported back to the master node, where the kubelet is the one who will report it back to the master node again. So that is the concept, team, here. That's a very simple one that you can have it accordingly. Okay, now this is how, team, you would prepare a Kubernetes cluster. And then here we did something called as, okay, Docker node ls to know the cluster members, Docker node inspect to do more about it. Now in order to create a service, a group of services, we do Docker service create. These are the commands that you're using it to create multiple containers, check the node status, everything. Now here also we'll be doing the same thing again. If I want to check the nodes, I see that I have another tool here, or another one which I need to install, which is called as kubelet. So it is called kubectl. kubectl, I say get nodes, which means that it is going to get me the nodes who are all part of the cluster, list the nodes of the cluster. I can do something called as kubectl describe node name, right? I say that node one. So here team, that is equals to the docker inspect command, as simple as that. And if I want to create containers, the same docker images team, it will not differ anything. The same docker images will be here as well. So we'll see that something called as kubectl create, right, deployment, I call it. A deployment is like your service. A deployment is nothing but a group of containers from a single image again, right? That is what a deployment. I do it. kubectl create deployment, my deployment hyphen image is equals to whatever the image that used like Nginx, right? Now I do it. Now here also I can scale it. kubectl scale deployment, my deployment, right, is equals to 10. That's how I can do it. Simply it will scale up, scale down. It will also maintain the desired state. So the functionalities wise team, they're all same thing, right? Whatever the features that is provided by the Docker Swarm, Kubernetes also provides the same thing, 100%. But only thing is that implementations are a little bit different. Now Kubernetes is completely an open source. Of course, the Docker Swarm is also an open source, but Kubernetes provides a better management by providing a various role-based access, right? The security is better in this one. There are multiple features that are available within the Kubernetes technology, which are not yet available with the Docker Swarm technology. Okay, so that is the reason people are preferring to use Kubernetes more than the Docker Swarm, such as an auto scaling, customized networking. So these are all things available. Now this is just for introduction team. I'm just giving it, not going to do this one, but just for introduction or what exactly is Kubernetes. Kubernetes is also a container orchestrator, which will help us deploy the containers across multiple worker nodes or multiple things, whatever it can be. We'll always be interacting with the master node here as well. We create a cluster, we manage the containers in the cluster and enable the access to the end user, ensure that the end user is accessing the application that is running inside the cluster. With their dynamic nature, container orchestrators will manage them in better way than we normally do. Okay, so this is about the container orchestration, containers, how to run containers, how to build the Docker images, right? How to run container orchestration solution, everything. So I'll stop here. If you have any questions again, let me know. We can discuss it. Why we prefer Kubernetes over the Docker Swarm? As I was telling it, there are certain features such as that. Okay, there is a feature called as auto scaling, right? There is a feature called as auto scaling, which is not present in the Docker Swarm, which is called as auto scaling, is not available. The role-based access, we call it RBAC. If I want to provide the cluster access, I can give a role-based access. Let's say that I'll ask you to maybe check read-only permission for you. I may give your colleague read and write permissions. I may give another colleague with administrator privileges. All these things are manageable easily within the Kubernetes cluster. Now it is also having container runtime, customizable container, right? Like customizable container runtime, we call it. Means instead of Docker team, what are the other containerization technologies you have it? What are the other containerization technologies you have it? I said containerization, container runtime. I told you yesterday, right? Somebody asked me, I believe. Instead of Docker, can I run anything to create a containers? Rocket. I told you right yesterday. Rocket, containerd, right? Containerd or LXD. These are the multiple containerization technologies. Mesos is container orchestrator, Atul, right? LXC, that's correct. LXC is also available, right? So these are the multiple other container runtimes, right? Means that instead of a Docker, I can use all these things. Also means Kubernetes is flexible enough to use all these things. But a Docker Swarm, if I use it, I must use Docker only, right? And if I want to get this RBAC feature and everything, I need to go for the enterprise version of Docker, so that I'll get enhanced features in the Docker, like providing the management layer in a better way. But without anything open source one, Kubernetes has the best management layer when compared to the Docker Swarm. This is the reason people are preferring your Kubernetes over the Docker Swarm. Right, so can you please give us a brief of Docker Compose? Docker Compose is a YAML file, Vinay. So Docker Compose is a YAML file with which you will be able to run multiple services. For example, how many services do I have here? Here, think about it, a Docker service create command with which I'm able to create multiple containers from a single image, right? Now think about it, right? I want to provide multiple other parameters like adding volumes, more properties to my containers while I'm running it. That is the first option. Second thing is that I would like to create 5 of Tomcat containers, 5 of Nginx containers, 5 of database containers, all of them together I want to create it. Now, how would I do that again? So it is better practice that if you need to write a compose file, right? Docker compose is a orchestration again, just like writing a Docker compose file will let you create containers from multiple services, let you create multiple services which are having multiple containers behind it in a single go, for which you need to write a YAML file scripting, right? For which you need to write a YAML file scripting with which you will be able to do it again. Just like a Docker Compose is a YAML script with which you will be able to create multiple containers from a single thing accordingly. Okay, so that's how you can understand about it. So if possible, please cover one or two practical. We don't have that much time, Rajan. I'm sorry, but we do not have the term permits. Auto scaling means that we will set it to a default, then always it's gonna create that many, right? It's not like that, Pandit. It's on the real-time event. Let's say that there are, see, for current load, let's say that I usually get every day 100 requests for which I create 2 containers. But let's say that on Wednesday or Thursday, I'm increasing the number of requests to 200. So on a certain event that is happening, it on that basis, I want to increase the number of containers dynamically, right? You watch the incoming request, then increase the number of containers to bring the stability to your application. That is called as auto scaling. Do you have documentation on the Kubernetes command that we can write in thing which we have provided? I think I'm not sure if I have it here. Let me check if I have it here. I think there is a documentation available here with a simple one. You may try this out, right? You have this installation document. You have all the commands available here. Okay, Atul? Please do try this one out on your own. I have given the necessary commands and everything, right? So go to the pods here. You can try that kubectl get pods. Everything is available. Okay. Please do try these things, team. If you have any questions, again, you can ask me. I'll try to help you. Okay. I do give a clear picture on what is Kubernetes and everything here. Please do go through that. Okay. Is it everybody okay with that? Please do read out the documentation, team. There is a lot of data here which we given, so please go through it and make yourself comfortable with them accordingly. Right, so great, team. So I'll stop it here then for today. I hope you all enjoyed it. We'll see you tomorrow. Tomorrow is the last day, which I'll be showing you a couple of other technologies, which are Nagios and Splunk, and then we will see the necessary, I think. Right, that's okay. Okay, just give me a second, Atul. I'll give you the instructions for you. Okay. So here you go, Atul. I'm pinging the, pinging the steps to uninstall it. You may copy it. Let me know if you're able to see it. Able to see it? Okay, great. So copy it and run them. You will be able to remove it. Okay, so that's to uninstall the Jenkins team on a server that you have run it already. So just go through that. Okay, then team, thank you so much. I'll see you tomorrow. Have a great day. Take care. Good night.